Okay, here we go. Finite math. This is section 3.4 on linear programming. It's a continuation of what we've been doing. And hopefully this will make pretty good sense by the time I get done. This will finish chapter 3. I'm going to start out. This is the example that's in the book, and then I'm going to follow up with an example that's not in the book. The first example is a maximization problem. Second example is a minimization problem, which we haven't done a whole lot with those, but I've got a good one for you. Okay, so in this example number 1, it's on investment planning. A pension fund has $30 million to invest. That money is divided among the treasury notes. I'm going to go notes, bonds, and stocks. The rules for the administration of the fund require that at least $3 million be invested in each type of investment. That is, at least half of the money should be invested in treasury notes and bonds, and that the amount invested in bonds not exceed twice the amount invested in treasury notes. The annual yield for the various investments are 3% for treasury, 4% for bonds, and 6% for stocks. Okay, so I went ahead and put some things together. And so first of all, X is going to be the amount for the notes, and Y is the amount for bonds. Now, at first, I thought, okay, let's let Z, the letter Z, represent the amount for the stocks. But the problem with using 3 variables is this method doesn't work, this linear programming using a geometric approach, because we graph, and we graph in 2 dimensions, not 3, so you cannot use Z. So what I did was I represented the money for stocks in terms of what I already had. So I've already used X amount of dollars here and Y amount of dollars there. And I had 30 million total. So if you take the 30 and subtract the amount I use here, this whole thing is going to represent the money for stocks. Think of it this way. If I had 5 million there and 10 million here, if you wanted to find the amount here, wouldn't you take 10 plus 5 and get 15? And then 30 minus 15 gives you 15. That's what I did here. I subtracted the sum of those two. This is in terms of X and Y. Okay, so now what about the inequalities? And this is one that you can't really come up with a table. It'd be kind of hard to do. But going back to, let me see if I can find my... Okay, so each of these has to be at least 3 million. That means X has to be greater than or equal to 3. Y has to be greater than or equal to 3. And this number here, that 30 minus X plus Y, has to be greater than or equal to 3. Let's play with that a little bit. That's 30 minus X minus Y greater than or equal to 3. So if you got negative X, negative Y, I'm going to put the 30 over here. That becomes greater than or equal to negative 27. And if I multiply everything by negative 1, that makes that a positive X, makes it a positive Y, makes that a positive 27. And remember, when you multiply by negative, it flips the sign around. So far I've got 1, 2, 3 inequalities. This makes a whole lot more sense than what I started with here. Okay, what else do I have? Well, let's see. Let's go up to administrative fund require at least $3 million be invested in each type, and that at least half the money should be invested in treasury notes and bonds. Treasury notes and bonds. Well, that's X plus Y. So X plus Y. It says at least half the money should be invested. So that means at least means greater than or equal to half of how much do we have to invest? 30. So that means X plus Y is going to be greater than or equal to 15. The amount invested in those two has to be more than half. So that gives me another inequality. Okay, and then the amount invested in bonds not exceed twice the amount invested in treasury notes. So the amount invested in bonds, that was Y. The amount invested in bonds not exceed, so that means it has to be less than or equal to the amount invested in treasury notes. Well, treasury notes were X. Twice X, 2 times, so that'd be 2X. So that gives me another one. Okay, and then let's talk about the profit function. Didn't leave myself enough room. But if you look at the last line here, the annual yield is the same thing as profit. In stocks, they call it yield, but it's the amount you're going to make off of it. The annual yield for the various investments are 3%, 4%, and 6%. So 3% is 0.03. So that's 0.03 times X. And then it was 4% for bonds, so 0.04, and bonds is Y. And then it's going to be 6%, 0.06, times this thing right here, that 30 minus X plus Y. Got my parentheses in the wrong place there. So let's play with that a little bit. Okay, so I got 0.03x plus 0.04y plus, if I take 0.06 times 30, that ends up being 1.8. And then I'm going to take, actually I did have that on the same place. 0.06 times 30 gives you that, and then this is 0.06 times a negative x, so that's minus 0.06x. And I'm going to have the same thing here, minus 0.06y. Run out of room. Now, if you simplify all that, for example, I got, it's 0.03x. Well, let's put the 1.8 first. Okay, so that takes care of that. And then of the x's, I got 0.03x minus 0.06x. That's minus 0.03x. And then if I did the same thing for the y's, it's 0.04y minus 0.06y. So that ends up being minus 0.02y. Okay, I know that's confusing, but it's a typical problem that you're going to have in everyday life. Okay, so I've got, 5 inequalities, and now I've got my profit function. We'll just call that P. P equals all of that. What's next? Well, we're going to graph it, and I've went ahead Well, I did have it all graphed. Okay, so let's see. I'm going to change my writing utensils. I'm going to make it smaller so I can probably see it a little bit better. We'll get my straight edge out. Okay, so first of all, x has to be greater than 3. So we'll just draw this. So if x is greater than 3, greater than or equal to, that would be all of those. And if y is greater than or equal to 3, that's all of those. Hit 3. Okay, let's go to this one here. X plus y is less than or equal to 27. So 27 is here, 27 is here. So we're going to draw our lines. And then if you look right here, it says less than or equal to. So that means it's going to be everything below the line. So right now it looks like my answer is going to be somewhere in this triangle, but I still have more. This one says x plus y is greater than or equal to 15. So 15, 15, and I graph that. If I did it right, those should be parallel. And this says greater than or equal to, so I'm going to shade in all of that. So now if you look at this little figure right in here, that's my answer so far, but I still have one more. Y less than or equal to 2x. So that's an intercept of 0 and a slope of 2. So if I went up here and over here, that's going to look something like that. And it's less than or equal to. So when I shade it in, let's see if I can do this real quick. Okay, I'm going to turn this around. I can shade it better if I do this. Okay, now you can see your figure. And the reason that we did the whole figure is, oh, I made a mistake. This should not be shaded in down here. My figure should be this. I'm rushing, trying to save time. That should be my figure. And the reason I did all that is because I got to find these points. You don't need to, but I think I'm going to label these. Let's call this one A, B, C, and D. And then we have to find where those all intersect. So let's say A. A is the intersection of this line. This was y equals 2x. This line was x plus y equals 27. This one was x plus y equals 15. And then we got y equals 3. And this was x equals 3, but I don't see any need for that one right now. Okay, so if I want to find this point, this is the intersection. A is the intersection of y equals 2x. And this one here where x plus y equals 15. I think what I would do here is just substitute. I'll put the 2x in for the y. So it becomes x plus 2x equals 15. 3x equals 15, which means x equals 5. And if x equals 5, then y would have to be equal to 10 because they add up to 15. So this point would be 5, comma, 10. Okay, let's go to B. B is going to be a little bit easier. B is the intersection of this line, which is x plus y equals 15, and this line, which is y equals 3. We can do this mentally. If y equals 3, wouldn't x have to be 12? So that means this would be 12, comma, 3. Okay, point C. Point C is over here. That's the intersection of this line, which is x plus y equals 27, and again, y equals 3. So we can easily look at that and say, well, x would have to be 24. So this point would be 24, comma, 3. And last but not least, we have to find D. D's probably going to be the hardest one. D is on that y equals 2x. And it's also on x plus y equals 27. So again, I would probably substitute on this one. I'd put the 2x in here, so you got x plus 2x equals 27. 3x equals 27. So x equals 9. And if they add up to 27, then y has to be 18. So that's the point 9, comma, 18. I don't really care how you come up with the points because you've been taught several ways. As long as you get the right answer, that's all that matters on getting those. Okay, so now that I've got the picture, I'm ready to take each of those and plug them in. Into that profit function. So if you remember, my profit function was, all I'm doing is copying from that previous page up here. P is equal to 1.8 minus 0.03x minus 0.02y. And then I'm going to take and find the profit off each of those points. And I'm going to copy those down. So I want profit at 510. That was point A on my picture. I want to find the profit at 12.3. I want to find the profit at 24.3. And I want to find the profit, the last point was at 9.18. And again, all I did on that is I took my picture, 510, 12.3, 24.3, and 9.18. Those are the ones I put here. Those are my vertices. That's what you're supposed to do. Okay, so as we go through this, I'm going to take 1.8 minus 0.03, and x is 5, minus 0.02, and y on this one is 10. So let me get my calculator, and we'll cheat here. Let it do the work. So it's 1.8 minus 0.03 times 5 minus 0.02 times 10. And I got 1.45. Now, just a point of reference, 1.45, that's 1.45 million. Okay, so the next one here, it's going to be 1.8 minus 0.03 times 12 minus 0.02 times 3. And that number, I've got it over here, so I'm just going to write down that's 1.38 million. And the next one, I know this is becoming repetitive, 1.8 minus 0.03 times 24 minus 0.02 times 3. And that one is going to end up being 1.02 million. And then last but not least, 1.8 minus 0.03 times 9 minus 0.02 times 18. And this one, 918, it should be 1.17 million. Okay, you've done all the hard stuff. Now you're ready for your answer. We're trying to maximize the profit. So I'm just going to say maximum profit is equal to, all we're doing is looking at the biggest ones here, and it's going to be 1.45. It's 1.45. I'll put a big M out here. That means million. And that happens at, well, X was, if we go back to the beginning, or let's do it this way. It means we're going to invest 5 million. Here's my paper at. There we go. 5 million in notes. Okay. The Y value represented bonds. So the Y value on that was 18. So 18 million in bonds. And then how much in stocks? Well, remember it's 30 minus those two there. So 5 plus 18. 5 plus 18 is 23. 30 minus 23, 7 million in stocks. So if you're a stockbroker or some type of investment firm, you can see how you would use this. As you go along, you don't realize it now, but as you get older and you accumulate some wealth, and some of you will play the stock market or the bonds or whatever. In other words, you'll invest your own money, and you'll need to know how to do some of this stuff. Right now, probably not. Okay, that's example 1. Let's go to example 2. This is going to be a minimization problem. And let's see what happens here. A nutritionist advises an individual who is suffering from iron and vitamin B deficiency to take at least 2,400 milligrams of iron, 2,100 milligrams of vitamin B1, which is thiamine, and 1,500 milligrams of vitamin B2, which is riboflavin, over a period of time. 2 vitamin pills are suitable, brand A and brand B. Okay. Each brand A pill contains 40 milligrams of iron, 10 milligrams of vitamin B1, which was thiamine, and then riboflavin was the other one. And so it's 40, 10, and 5. So right there, those 3 numbers end up right here. The brand B contains 10, 15, and it says 15 for each of the other 2. So it goes 10, 15, and then 15 again. And then there's a cost And this is 6 cents. Now you could do this a variety of ways. You could say 6 cents, or you could go $0.06. And this one's going to be this one's 8 cents, or 0.08. Okay, and the last thing was we need these numbers right here, 2,400, 2,100, 1,500. Those go here, and these are your minimums. 2,400, 2,100, and 1,500. And that's how you fill out the chart. Inequalities. I'm going to have 40x plus 10y. And then these are minimums. So when I do this, it's got to be greater than or equal to 2,400. So when you're minimizing something, minimizing a cost, then each of these would be greater than. It's kind of backwards. So the next one would be 10x plus 15y is going to be greater than or equal to 2,100. And then you're going to have 5x plus 15y greater than or equal to 1,500. And then don't forget you got x greater than or equal to 0 and y greater than or equal to 0. And my profit function, I'm just going to use 6 and x. We'll remember that represents 6 cents. So that becomes 6x plus 8y. Okay. So now we need to graph it. I think I'm going to go the easy route here. And I'm just going to go ahead and draw the graph. Take a little bit of time off of it. But if this is L1, L1 is going to hit at an X value of 60. So we'll put 60 here. And it's going to hit at 240 up here. So when I draw my line, it's going to look something like that. And greater than, I'm going to do everything to that side. L2, this is going to hit at 210 on the x-axis, and it's going to hit at 140 on the y. That line goes across here, and that's everything up in here. And then L3 is going to hit 300 here and 100 there. So I'm going to draw my line, and that's everything above this direction. So everything's greater than, so that would be everything out in here, which we haven't really done that before. So don't forget x is greater than 0. So this flattens off up here at the top. Some people forget to put that. So you got an edge. I'll darken that, make it stick out a little bit better. Okay, and then you got an edge down through here, and then you're going to have an edge here. And an edge here, and then that keeps on going straight out that way. So this is an unbounded region going up that direction. See if I can darken this, make it look a little better. Yeah, it looks a little bit better. Okay, so now we got to find the vertices. That's what that principle on linear programming. Okay, where are our points going to be? Well, I'm going to have a point right in here. Let's call that A. I got a point right in there. That's B. I'm going to have a point right here. That's C. And I'm going to have a point right there. That's D. Okay, so if I want to find A is the intersection of x equals 0 and this line here. And that one was, this was L1. I should have put that down. L1, L2, L3. So L1 was 40x plus 10y equals 2400. So if x equals 0, I got 10y equals that. That means y equals 240. But I kind of knew that because that was my intercept right there. So anyway, that's the point 0, 240. I'll put it up here also. 0, 240. What about B? B is the intersection of L1 and L2. So L1 again was 40x plus 10y equals 2400. And L2 was 10x plus 15y equals 2100. Probably linear combination on this one. I'm going to multiply the top one by 3 and the bottom by 2. So if I do this, I need to write a little smaller. That's 120x plus 30y equals 7200. On the bottom, I'm multiplying by 2, so that becomes 20x plus 30y equals 4200. And we'll subtract. So 120 minus 20, that's going to be 100x. The 30y's drop out, and 72 minus 42 is going to be 3000. X is going to be 30. And if you plug back in, I'll cheat because I've already got it worked out here. Y is going to be 120. So that means point B is 30, 120. So 30, 120. Point C is the intersection of this line, which is L2, and this line, which is L3. L2 was 10x plus 15y equals 2100. And L3 was 5x plus 15y equals 1500. Oh, this will be easier. I can subtract these because those guys are going to drop out. 10 minus 5 is 5x equals, that's going to be 600. X is equal to 120. If you plug back in, y is going to be equal to 60. So that's the point 120, 60. So up here, that's 120, 60. And then point D is on L3. L3, you had 5x plus 15y equals 1500. And it's also on y equals 0. That's the x-axis. So that's going to tell you if y is 0, then x is going to be 300. So D is going to be at 300, 0. Which again, we kind of knew that because that was our intercept. Okay. Now we're ready to start finishing things up. Go back up here. My profit was simply 6x plus 8y. And what I'm going to do is plug each of the points in. So I want to find the profit at 0, 240. And you know what? I got to go back here. I shouldn't have called it profit because it's a cost. This should be cost. The cost at 0, 240. And then the cost at 30, 120. And then the cost at 120, 60. And then the cost at 300, 0. So on this one, we would take 6 times 0 plus 8 times 240. And I know that that is going to be $19.20. Okay, let's spare the pain. You know how to plug in. When you put in 30, 120, that's $11.40. When you put in 120, 60, that's going to be $12. And when you put in 300, 0, that's going to be $18. Okay, we want minimum cost. It's maximum profit, minimum cost. So again, all you're going to do is look for the smallest number up here. It looks like that's going to be this guy right here, 1140. We got that at 30, 120. So you could say that would be 30 of the brand A tablets and 120 of the brand B. Okay, so in this lesson, I showed you 2 examples. The first example had to do with maximizing a profit. Sometimes we just call that a max problem. And the second one, I was minimizing a cost. And most time we just call that a minimum problem, or a min. So you got max and mins. Okay, and with that, that takes care of chapter 3. I'm ready to sign off. Let me know if you have any questions, and see you next time.